Alright, we're going to take a look at a data set which is way harder than anything we've ever seen before, but also a little reminiscent of how the final project is. So I went ahead and I paused the video to write out the code so that we can make this video faster. And it turns out this data set wasn't as cool as I thought it was going to be, so I'm kind of glad I did that. But I kept in mistakes, so I tried not to delete stuff, except misspellings, which were embarrassing. But so I started off by reading in the stock data, and this stock data has the price of stocks and the price of the number of options. No, I think that was the price of options. The percent out. I looked up what all these meant at some point, but now I don't remember. It's a made-up data set anyway. So our goal is to predict the stock price, but that was a problem if I call it stock, and then I have a variable in the data stock that's also called stock. So I decided not to rename it that. I'm going to call it finance instead. And then I did a plot of finance, which I decided was not exactly a good idea because all you get are these little tiny graphs with dots all over the place. So instead I said, all right, show me what are the names of the variables in this data set, and then I plotted stock, which is what I want to predict, versus each of these variables. Now options here is interesting. You can see these clumps, but these clumps don't depend on options. It's not like there's a clump for low options and a clump for high options. It seems to be there's something else that is causing stock prices to be high, medium, and down to low. So then I looked at some of the other graphs. That one also I don't see much going on. Nor here, but look at type. Why is it that we have a high clump, medium clump, low clump? It's because of the different types. So type is obviously very important. And distance is clearly important because there's a huge relationship between stock and distance. But it's not a straight line relationship. This is clearly curved. And looking at locked, I don't know if I really see anything. So what do I know so far? Distance is squared and type is a big deal. So I made my fit, and I did distance and distance squared because I think it should. I also made sure type was in there. And when I ran this, I looked at the residuals, and there's clumping here, and there should be, right? Because we have 4 different groups which all have very different predicted values. So seeing the 4 clumps isn't necessarily bad, but as you go along the residuals, do you see any patterns? And the answer was no. That's looking all right. That's decent. But down here, do you see the dinosaur track thing going on here? That made me feel like there was something else to find. So let's go through each of these variables. Looking at stock, I don't see much. Yes, there's still 4 clumps, and there will be because there's 4 distinct groups, but I don't see it depending on stock. So then I looked at options. Whoa! Yeah, definitely something going on there. But percent out looks good. Open change looks good. Type now is all evened out, which was not what we saw before, and so that's good. And distance. It used to have this big quadratic. It's not. It's all leveled out. And locked. Okay, locked we see a difference. The no's tend to be up here, and the yeses tend to be down there. Combine that with the fact that options seem to have 2 crisscross lines. I'm going to draw options. Oh, I remember I got this error. Locked yes, not found. Oh, because I needed to call it finance $ locked yes. Remember I told you I was going to try to leave my errors in? So there is the plot of options based on locked, and you can see that locked no looks one way and locked yes looks very different. So my next fit should have an interaction between locked and options, and that should fix that little design. Let's see if the residuals look better. And they do. Remember that dinosaur track? That's gone now. We still have a little bit of squiggle here, but this is definitely an improvement. Let's look at stock, and options now looks good. Remember how it had those great big crisscross? It doesn't have that now. It does sort of look like maybe it's tailing out here. Could this be the one that was logged? And I looked in my notes, and it said that there was something logged in this data set. And so I thought it was options at this point. And ooh, open change. You see that? Look how nice that looks. That's like perfect residuals. Type and distance. And locked before looked very different. Now that's evened out. Okay, so we've improved it. But could that options need to be logged? And options was in the interaction. So maybe locked was supposed to be interacting with log options and not just options. Like, okay, good. I think I've found. And then I got this error. I remember this. What's the problem? Well, if if I look at the histogram, which you have to have finance $ options, you can't just do options. So we've got a lot of options sitting here at 0. Are they actually 0? And the answer is yeah. The smallest options value is 0. Well, you can't take a log of 0. It's negative infinity. It's a problem. And you're asking what number can I take to a power and get an answer of 0? That's not going to work. So how many zeros do I have? I have 251, which was kind of disappointing. I thought, oh, if there's only a few zeros, I'm going to delete them and then try logging. And that wasn't an option. So then I did a horrible cheat. Please do not ever tell your math teacher I did this. I took options and I added 0.01. What does that do? It makes it so my zeros aren't 0 anymore. And I'm hoping it changes the numbers so little that it's not going to be a big deal. And this is totally mathematically cheating. There's no way that could actually be what the dataset needs. But I really thought there was a log somewhere in this dataset. So I thought, okay, let's try this and just see if options getting logged actually helps us. So let's look at our residual plot. And that does not, okay, this looks bad. That looks bad. I'm not liking it. And so I thought, okay, let's look at the residual plot by options. Yeah, no. Now, if I look at a summary, the log of options does seem significant. It's just not fitting the data well. So maybe it's supposed to be locked times options and then a separate log. Again, the mathematicians in the room are groaning because x and log x both in the model? No. Plus, I still have this 0.01 cheat. So terrible, terrible mathematical notation, but I was fishing because there's supposed to be a log in this data set. That's why I put it in the chapter where we talk about logs. And the residuals, okay, I'm going to say this is at least better than it was before. Okay, options still isn't looking much better. We still have these outliers here. And then I went to my summary and I looked at the p-value for the log, 0.941. So the data says stop logging, okay? Options was never meant to be logged. There were so many ways to know that options was not supposed to be logged. So then I said, all right, let's go back to what we had before. This really was a good model. And why do we have these outliers on options? Because it's rare to have stocks that have option prices so very high. So, all right, fine. So I remember what I was doing at this point. I was looking at what should I do with my model. And let me size this out so you can see the whole model all at once. What should I take out? Well, looking at what things are big in p-value, commodities here 0.8, and the other type energy is 0.6, and other was 0.1. It looks like separating the stocks by type actually isn't helpful. But at the beginning of this, I said type is very helpful, which seems like a contradiction until I looked at this plot. If I can size my window out. This is the relationship between the type of stock and the distance. And it's a nice, perfect relationship. So if I know the distance of the stock, I don't need to know the type. So there's high multicollinearity between distance and type. I don't need both of them. And in this case, distance is what's working better according to the p-values. And so I got rid of type, which felt really weird because if I had to guess what was going to happen, that wasn't what I was going to guess. Next, open change got taken out. And after that, it looks like distance. But distance squared should be in the model. So should you delete distance or not? And I thought, okay, which one do I want to justify? And I was mad that I had lost the log, and I was in an ornery mood, and so I said, I'm going to justify whichever one is easiest, and so I left distance in. I said, let me check my residuals. I should have resized my window, but usually after you're done with all this model selection process stuff, you want to check that you haven't messed anything up real bad. And these all look really good. Okay, so now I want to do a picture to show distance. So I have my distance hat. And stock had a whole bunch of different things in the summary. Here's my summary for stock. But since I'm only plotting distance, And since I was still kind of mad at it, I decided I'm only going to plot the distance piece. Now, if I made up values for percent out and options and locked yes, the only thing that would do is shift my picture up or down depending on the values I chose. But the distance versus stock relationship is going to stay the same. So, being in an ornery mood, it's called dist hat, and then I called it distance. No, I'm sorry, dist hat. So plot it. Okay, it looks like that, and then I made my plot all pretty and nice. Oh, great. So now I can see the relationship. As distance increases, stock price isn't affected a whole lot, unless you get to the really high values, in which case it rockets up like that. Now, if we're going to do the relationship between locked and options, first thing I did was I said, okay, tell me what's 0. 0 is no, and 1 is yes. Okay, then make my options. Let's start with 0 and plot what it looks like. It looks like that. And what happens if I turn lock to be 1, which is a yes? It looks like that, which now the picture was down. And normally I'd just go back up to here in my plot and kind of change the y-axis, but I told you I was trying not to cheat. So I said, okay, now let's add this y limit that goes from -10 to 15. There's no, and there's yes, except I still didn't like that. For one thing, we have stock prices that are negative, and they shouldn't be negative. So why is that happening? It's because of the other values, such as distance, and I can't even remember what the other things in the model were, but it's those other variables in the model that I didn't use that caused my graph to shift down. So I'm going to add 5 to the graph, and that's going to make this shift up, and then I'm going to resize my window to go from 0 to 25. Now, that's not cheating because this is the same line, the same slope, the same curve. I've only shifted it up. And if I worked really hard, I could figure out what value of distance and percent out would shift this graph to be just perfect. And I'm lazy and mad at this data set, so I didn't do that. There's my red ones. Give me a legend, and we need to make it nice. But let's jump to the article. And so I copied these. If this was part of my real article, I would delete this before I handed it in, of course. But percent out is easy. It's just a linear effect. As it goes up, stock price is going to drop by 0.00995. Remember, this is scientific notation, so I had to move that decimal point 3 times. And then distance, I said it stays pretty level for low amounts, and then it climbs for higher amounts. Look at the picture, because picture will fix a whole lot of problems. Stock price, if it's not locked, then it starts out here at about the same price as if it was locked, but then it goes up pretty steeply. When it is locked, it starts out at about the same price, but then it actually drops ever so slightly, as you can see in the picture below. So there's all the different effects. It did not have a log, which is very disappointing, so it looks like I need to find another data set, and we're going to make another video.